Okay, question 9. It's given us a quadratic equal to this thing here, and it says, when will we get real solutions? We know we'll get real solutions when the discriminant is greater than 0. So I'm going to move everything to the left hand side and say I want the discriminant of this thing I'm going to expand the bracket, so we're going to get minus 2kx and we're going to get plus k. I want that to be, I want the discriminant of this to be greater than 0. So it's going to be useful to have the x terms together. So that's going to be, I've got a 2 and I've got a minus 2k. Because now I can treat that as my b term in b squared minus 4ac. And my c term is going to be the 11 plus the k, the bit without the x or the x squared. So we'll get real roots. It's always good to tell the examiner what you're doing. So real roots when b squared minus 4ac is greater than 0. So for us, b is 2 minus 2k. So 2 minus 2k squared. Going to have another one of these square brackets to expand. Minus 4 times just 1 times 11 plus k. So again, expanding these brackets, that's going to be 4 take away 8k plus 4k squared minus 44 minus 4k needs to be greater than 0. So that's going to put the leading coefficient to the front, so 4k squared minus 12k minus 40 needs to be greater than 0. I can divide by 4, so that's going to be k squared is k squared minus 3k minus 10 is greater than 0. And this is now a quadratic. So we know that quadratics are greater than 0 when we are looking at the values from here onwards and here backwards. So we now need to know what these 2 points are, which we can get by factorising. So I'm going to factorise this quadratic. This one's fortunately quite easy to factorise. We're going to have a 5 and a 2. We want negative 5 and positive 2. So this will equal 0 when k is equal to 5 or when k is equal to negative 2. So my graph wasn't great because it doesn't intercept there. Let's get rid of that and draw a new one. So we've got a intercept at negative 2 and at 5. So this is our graph, and it will be greater than 0 from 5 onwards and from negative 2 backwards. So in other words, we will get 2 distinct roots when k is greater than 5 or when k is less than minus 2.